You know that feeling, right? You get a positive result on a medical test, and your heart just sinks. Your mind immediately goes to the worst-case scenario. But what if I told you that a positive result, even from a test that's supposedly really accurate, might not mean what you think it means? Yeah, let's break down this really strange but super important idea.
So let's just imagine this for a second. You go in, you take a test for some rare disease. The doctor tells you, hey, this test is highly accurate. And then it comes back positive. So what's your gut reaction? I mean, for most of us, it's probably, well, I guess that's it. I have it. But how sure should you really be? 90%? 95%? Well, let's actually figure it out.
Okay, so the very first thing you have to know, and this is super important, is that this disease is rare. Now, this isn't just some throwaway detail. As you're about to see, it is the absolute key to this entire puzzle.
So how rare are we talking? Well, this disease only affects 3% of the population, just 3%. That means if you pick someone totally at random off the street, there's a 97% chance they don't have it. This starting point, this 3%, is what's called the pre-test probability, or the base rate. Remember that term.
Now, what about the test itself? Well, we're told it's a good one. When somebody actually does have the disease, this test is pretty darn good at finding it. To put a number on it, this test correctly flags 75% of people who are genuinely sick. This is what we call the test sensitivity. So you hear that, right? A rare disease, but a 75% accurate test. A positive result feels pretty convincing, doesn't it? Well, not so fast.
Here's the thing. We actually don't have the full story yet. It turns out, to really understand what that positive test means, just knowing how often it's right isn't nearly enough. We need a few more crucial clues to really solve this medical mystery.
You see, just saying a test is accurate is kind of vague. I mean, a test can be right or wrong in a couple of different ways, right? It can correctly say someone is sick, and it can correctly say someone is healthy. And of course, it can get both of those things wrong too. We have to look at all four possibilities.
In this chart here, it lays it all out perfectly. You've got 4 boxes. A true positive, that's when the test says you're sick and you actually are. Awesome. A true negative, the test says you're healthy and you are. Perfect. But then you get the errors. A false positive, that's the scary one, where the test says you're sick, but you're actually perfectly healthy. And a false negative is when the test gives you the all clear, but you're actually sick. Understanding these 4 squares is everything.
Okay, let's put some official names to these clues we're collecting. First up is prevalence. This is just that base rate we mentioned earlier, that tiny 3% of the population that has the disease before anyone even takes a test. Think of it as our starting belief. Next, we have sensitivity. This is that 75% number we saw. It basically asks the question, if a person really has the disease, what's the chance the test will catch it? This is our true positive rate. And finally, this is the big one we were missing, specificity. This is the other side of the coin. It asks, if a person is totally healthy, what's the chance the test correctly says they're healthy? For our test, let's say the specificity is 85%. Now that also means there's a 15% chance of a false positive, a 15% chance it'll raise a false alarm on a healthy person. That's a crucial number.
So we've got our clues, right? We know how rare the disease is, and we know how good the test is at spotting both sick and healthy people. So how do we put it all together to get a real answer? Well, we're going to use a really powerful way of thinking called Bayesian reasoning.
This quote from our source material on clinical stats just nails it. It's not about one single number, it's a process. You start with your initial belief. How likely is the disease to begin with? Then you get new evidence, the test result, and you use that evidence to update your belief. It's just a formal way of changing your mind when you get new information.
You can think of it as a super simple 3-step process. 1. What do you believe before you see the evidence? For us, that's our 3% prevalence. 2. How strong is that new evidence? That's all about the test sensitivity and specificity. And 3. You combine 1 and 2 to form a new updated belief. That's it. It's just a logical way to think. All right, the moment of truth. We have our framework, we have all our clues. It is time to go back to that original question and finally solve this thing. We got a positive test result, so what does it actually mean? So, just to have it all in front of us, our pre-test probability or prevalence is a tiny 3%.
The test's ability to find sick people, the true positive rate, is 75%, and that crucial number, the false positive rate, is 15%. That means it will incorrectly flag 15% of all healthy people.
So here we are. This is the big question. We started with a 3% chance. We got a positive result from a pretty decent test. What do you think the actual chance is now? Is it 70%? 60? 50? Take a guess.
The actual probability that you have the disease, even after getting a positive test, is just 13%. Wild, right? Let that sink in for a second. 13. It's definitely higher than the 3% we started with for sure, but it is nowhere near the certainty you probably felt in your gut.
So why? Why on earth is it so low? It all comes back to that base rate. The disease is just so rare. Think about it. 97% of the people taking the test are healthy. So even a small 15% false positive rate, when you apply it to that massive group of healthy people, creates a huge number of false alarms. In fact, in our example, there are way more false alarms than actual true positives from the tiny group of sick people.
And this chart just shows the whole journey perfectly. We started way down here with a belief of only 3%. The positive test result was real evidence, and it did update our belief. It more than quadrupled it. But look where it moved it to. It took us from very unlikely to, well, still pretty unlikely.
And look, this is so much more than just a cool math puzzle. This way of thinking is absolutely critical in the real world, especially for doctors. It helps everyone avoid a really common mistake called the base rate fallacy, where we get so fixated on this one new piece of evidence, the test, that we totally forget about the starting point.
So if you take away anything from all this, let it be these key ideas. A positive test is not a diagnosis. It's just a piece of evidence. That starting probability, the base rate, is every bit as important as how accurate the test is. And putting those two things together is how doctors and patients can make much smarter, much more informed decisions.
And that really gets you thinking, doesn't it? This isn't just about medicine. It applies to news stories, to financial markets, to pretty much any judgment you make. It leaves us with a really big question. What other things in your life feel totally certain but might look completely different if you just stopped for a second and asked, wait, what was the base rate?